We want to look at this particular example in this very lesson. Remember, we are still on the same topic, distance and bearing problem. Let's go through it. Two cycles left a point P at the same time. The first cyclist covered 300 kilometers on a bearing of 296 degrees, and then the second cyclist covered 250 kilometers on a bearing of 206 degrees. We want to calculate, correct to three significant figures, the distance between the two cyclists. This is what I have for you in this very lesson. So we are saying that two cyclists left a point P. So let's identify our point P. Let's take it that this is our point, and this is what our P. At the same time, the first cyclist covered 300 kilometers on a bearing of 296 degrees. On the bearing means that we have to first draw our cardinal point. So we have our north, this is our south pole, this is our east, and then this is what our west. On a bearing of what 296 degrees, and as we have already learned, in bearing angles are measured from the north in a clockwise direction. And we know that if you are to start measuring from the north in a clockwise direction, 296 will be in this quadrant, right? So we are going to have, now once you have it, we draw our distance. So we have the first cyclist. So the distance is what? 300 kilometers. Now let's look at the second cyclist. The second cyclist covered a distance of 250 kilometers on a bearing of 206. So 206 degrees. So we are going to start measuring from the north in a clockwise direction. And we know that 206 will be in this quadrant. So we start from the north to this particular quadrant, and then we draw our distance. The distance is what? 250 kilometers. Now know that 300 kilometers is longer than what? 250 kilometers. Therefore, the distance between the point P and then the first cyclist must be longer than the distance between P and then what? The second cyclist. So let's call this point the second cyclist. Now once we are done, our task is to calculate for it with three significant figures, the distance between the two cyclists. So we want to calculate the distance between these two cyclists. If that is the case, let's join the first cyclist to the second cyclist. So this is what we want to calculate, the distance between this point and then this point. Since you don't know that, let's use x to represent it. To be able to find the distance between the two cyclists, which is represented with x, then we need to find this angle. This angle, we need to find it. Now we know that from the north to this terminal line is what? 296 degrees. And we know that the measurement from the north in a clockwise direction to the west pole, so this is the west pole, is what? 270 degrees. So if you want to find this particular angle, this angle, then we have to subtract 270 from what? 296, and it's going to give us what? This particular angle. So we are going to have 296 minus 270, that gives us what? 26. So it means that this angle is going to be 26 degrees. Now let's look at this particular angle. This angle. Now we said that The measure of the angle from the north to this terminal line is what? 206 degrees. That is what it was given in the question, 206 degrees. You also know that the measure of the angle from the North Pole in a clockwise direction to the West Pole is what? 270 degrees. So to find this angle, we are going to subtract 270 from 206 to give us what? This angle. So we are going to have 206 minus what? 270. That gives us what? 64. So this angle is what? 64 degrees. Now once we have this angle, let's sum them together to see what we are getting. So we have 26 plus what? 64. That gives us what? 90 degrees. Since this angle is equal to 90 degrees, this angle is 90 degrees, it means that this triangle is what? A right angle triangle. And whenever we have a right angle triangle, we can use the Pythagoras theorem or the trig ratio to find the length of the sides of the triangle. So we are going to redraw this diagram so that we can see it clearly here. The 90 degrees, which is this, is at point P. So let's identify it. And then we have the first cyclist. And this is what? The second cyclist. Now the distance from the first cyclist to the second cyclist is what? X. And then the distance from the first cyclist to P, the first cyclist to P is what? 300. So we have 300 kilometers. And then the distance from the second cyclist to P, the second cyclist to P is what? 250 kilometers. Now once we have this, we are going to apply our Pythagoras theorem to find the distance between the first cyclist and then the second cyclist, the first cyclist and then the second cyclist. So with the Pythagoras theorem, it says that given any right angle triangle, the square on the longest side, so this is the longest side, so we have s squared is equal to the sum of squares of the other two sides. So we are going to have 300 squared plus what? 250 squared. So we have our s squared is equal to, let's point this on the calculator. We have 300 squared will give us 90,000. And then 250 squared will give us 62,500. So we have our s squared is equal to, let's sum this together. We have 152500. Now let's take the square root on both sides of the equation. We have our x is equal to 390.512 kilometers. So we have to leave it in three significant figures. We are going to get 391 kilometers. Therefore, the distance between the two cyclists is as easy as that. So this is what I have for you in this very lesson. See you tomorrow. Bye bye.